Hello and welcome to Intro to Programming. I know what you're thinking right now. Last class I told you that we were done with Google Sheets, and here up on the screen I have a Google Sheet. So what's the deal? Am I a liar? The answer to that question is quite clearly yes. I am. No. I'm just using this to illustrate an example. We're not actually going to have to do anything in Google Sheets today. All right, we're going to use this to sort of talk about databases and how databases are designed to sort of minimize wasted space and maximize the ability to sort of keep data consistent across time. So this is just going to be used as sort of a tool. We're not actually doing anything. We're not going to be writing any formulas. It's just for me to illustrate some points. So last class we did VLOOKUP and HLOOKUP, and we saw that those could be used to sort of retrieve information from a Google Sheet to make it easier for a user to find something. All right, so like we wrote that little search box that could look up a student's grade on an exam. You created that little library system that could look up a book and figure out whether it was late or on time or what have you. And while all of those systems work, they have a lot of limitations, all right? And there's only so much we can do with a VLOOKUP and HLOOKUP and some if statements. So when you're talking about some of the world's biggest databases, there's no way they could function just on VLOOKUP, HLOOKUP, and a couple of Google Sheets. All right, think about something like Amazon. All right, so let me bring up Amazon really quickly. All right, Amazon has millions and millions of products. Let's say I wanted what do I want? A fork. Yeah, why not? All right, when I search for fork, it's going into its database and retrieving all of the information it has that matches the word fork. Now, we can already see that this is better than VLOOKUP and HLOOKUP because VLOOKUP and HLOOKUP could only give me back one thing. I'm already getting back lots of things. And the spelling doesn't have to be an exact match. Like this entry is called Amazon Basic Stainless Steel Forks. All I typed in was the word fork, and this was still smart enough to sort of return these values from the Amazon database. All right. None of that would be possible with just a Google Sheet and some VLOOKUP and HLOOKUPs. And then additionally, when I click on any one of these things, so let's say this looks like a nice fork, it further goes into the database and retrieves the exact information that I want. So there's no way that this site could exist without a database behind the scenes storing all of this important information, like it's $12.49 for a pack of 12 forks. Ooh, I can get pearl veg. Ooh, those are nice. Without a database behind the scenes. And that's what we're going to kind of see is that pretty much any major website that you use has a database behind the scene. If we think of IMDb, it's literally in the name. The Internet Movie Database, this is keeping a collection of pretty much all information that you might need on a given film. So I'll go with one of my personal favorites, Princess Bride. It's an incredible movie. If you haven't seen it, find it. So first of all, I accidentally hit an R. So Princess Bride, or I don't even know what that is. But it still showed up. It gives me multiple entries. So again, we're seeing that the database can be more flexible. I click on this and we're going to see that it's got all sorts of connections. All right. So one, it knows the film, but then it also knows the actors that are attached to that film. It knows the roles that they played. And if I click on one of those actors, right, it will then further take me to then everything that actor has done. So everything's sort of connected and linked together through this database. And that's what we're going to see is one of the major advantages of databases is that we can have these links and things can be connected. If we go back to Google Sheets here, like everything was sort of its own independent sheet. And yes, you can write formulas that go across different sheets, but it's not connected in the same way that a database is connected. So there's all sorts of limitations here that sort of prevent the type of functionality we want when we're dealing with like a modern day website or something like that. In addition, like the school keeps a database. So we have a database of all of the students in the school. We know their contact information. We know their address. That's right. I can look up any of your addresses and come hang out with you on the weekend. So, if you want to hang out with me, just let me know. I can figure out where you live. It'll be fun. That was weird. So anyways, it keeps track of your information. It keeps track of your grades. It keeps track of your classes. It keeps track of your teachers. And it kind of stores everything and links it together so that we can use that information in a valuable way. Spreadsheets, for all their benefits, aren't usually as useful when you start having these connections between things. So what we're going to talk about today is basically how databases are set up and how those connections actually sort of exist. So here we have an address book. First name, last name, address, state, zip, phone, email. Take a moment to appreciate the details here. All right, we've got Amy Amyson down to Zach Zaxon. So first of all, every name, every letter of the alphabet has a name. And then check out these addresses. Apple Street, Banana Street, Cranberry Ave, Gateway, Endive Way, Fig Drive, Grape Ave. Everybody lives on a street that starts with the same letter of the alphabet as their name. How great is that? Good old Ingrid Ingerson living on Incaberry Ave, or Jack Jackson on Jalapeno Boulevard. It's just all so good. Quinn Quinson on Quinoa Way. I impressed myself, I'm not going to lie. All right, so we've got this address book. So imagine we wanted to keep this address book. Now, these days, a lot of people have their home phone number, but they also have a cell phone. So let's pretend we wanted to allow the user to type in multiple phone numbers. All right, we could go to our sheet up here. I could right click and say insert a column to the left, and I could add a category for cell phone. And most people would probably have cell phones. So I'm just going to fill in some of these and say, all right, most people probably have cell phones. Every now and then you bump into somebody that doesn't, but most people these days have cell phones. Some people don't even have house phones. They just have cell phones. All right, so there we've got cell phones. But you'll notice I do now have some empty spaces in my sheet, which is fine. It's not a big deal. But that's like empty space that is kind of a waste. And if you're building a database or building a system, storage costs money, and you don't want to waste storage, even though it's cheap. If we can cut down on waste, cutting down on waste is a good thing. Now for this, it's not really a big deal, but what if they have a work phone number? And now we also want to keep track of their work phone. And maybe not as many people have work phones. Maybe only a few people have work cell phone numbers. And then, yeah, only a few people have work phone numbers, but like, what if there's like one or two people that have like a third phone? And I don't even know why they have a third phone, but like maybe they have a third phone, and who am I to like deny them their third phone? But we're seeing that if you want to accommodate more phone numbers, you're likely to end up with more wasted space, because what if what if there's like one jerk that has 5 different phone numbers? So this is their 4th phone, and this is their 5th phone. Now for this one person, I'm sorry, Edith, but you're going to be that person. All right, we've got all of this wasted space because most people only have 1 or 2 phone numbers. But if I'm setting up a spreadsheet or I'm setting up a database, this is all space that takes up memory that I'm now, paying for and supporting. And for most people, it's totally blank. So that's not great. All right, it's not great because I've got all this wasted empty space. And it could get even worse. Like, what if people have multiple addresses? Think about Amazon. Sometimes you ship gifts to other people. So instead of just having to keep track of one address, Amazon might have to keep track of multiple addresses. I could ship gifts to like 10 different people. All right. So I could have like address 1, address 2, and so on and so forth. And all of a sudden, it doesn't take a lot to see that very quickly there can be a lot of wasted empty space in my spreadsheet here. All right, because maybe Davidson sends things all over the place to different addresses. 45 Gateway, 44 Gateway, 43. I don't actually need to change these. I'm just illustrating a point here. I'm going to do it because why not? All of a sudden, it's very easy to see how you can have wasted space. And you might be saying, well, yeah, but like, how much space is this really? But start imagining that instead of having 26 people, I have 5 million accounts, or I have 100 million accounts, or I have 200 million accounts. And all of a sudden, this wasted space starts adding up to real memory that we have to pay for and real money that we're spending. Because even if it's blank, I have to allow for the possibility that somebody at some point might want to put something in there, which means I'm allocating the space even if I'm not using it. Right? So it's basically a giant waste and not a great way to handle things. So we can see that, if you want to add information, we can add columns, but unless everybody is using that column, you can very quickly create a lot of wasted space in your spreadsheet, in your database, whatever. So first things first, just adding columns to accommodate people is not a great way of doing it. For one, the empty space, and two, you're kind of forcing a limit on your system. Like, what if I suddenly need a 6th address? Do I have to reset up my whole spreadsheet to add that address? What if I need a 12th address, a 15th address? Like, when does it stop? This doesn't scale very well. And each time somebody needs a new address, if you're creating that column, you're creating it for every single person, which can lead to a lot of just wasted space, time, and money. So not a great way of handling it. All right. So the next approach could be, all right, well, instead of adding columns, what if I duplicate things? All right, so what if instead of adding columns vertically, what if I add rows? And if Amy Amison wants, or sorry, I just put it under Bob. So if Bob Bobson wants another phone number, we'll just, just say, all right, we'll give Bob Bobson another entry. And there's Bob Bobson. And then we'll just change this phone number here to, instead of 518, we'll make it 914. All right, so there we go. Now we have 2 Bob Bobson entries, same address, same state, same zip. They just have 2 different phone numbers. And then if Bob gets, I keep putting it in the wrong spot. And I did it again because I keep saying below instead of above. And then maybe Bob wants a new address. So we add another Bob Bobson. And this time, instead of on Banana Street, he lives on 44, something with a B. Yeah, I'm blanking. So we're just going to put it on Banana Boulevard instead of street. You like how I did that? which is clearly in California, not New York, which is clearly zip code 90210. And then assuming there's like another phone number here, we would have to assign some sort of phone number to it. But we'll just assign that original phone number. We'll assign the original email. And I could just start making different Bob Bobson entries across my database. So yes, I have some duplication, but that duplication is wasting far less space than when I had 20 extra columns, only a few of which were used by members of my database. So I could duplicate, all right? That would be another sort of way around this problem of growing the database and allowing your users to put in different information without necessarily having to add columns and wasting a lot of space. Now, the downside of this, of duplication, is it can create sort of data inconsistencies. All right, so what do I mean by data inconsistencies? Well, presumably at some point, just type in a random phone number there, Bob is going to update some information. All right, maybe Bob decides to change his name, and instead of going by Bob, he goes by Bobby, right, with 3 B's. Why 3 B's? Because why not? Now you have the issue of you have to make sure that you update multiple records in the database. And if you're not careful, maybe some of them get updated and some of them don't. And then all of a sudden you start getting inconsistencies in your spreadsheet or in your database, and it causes problems with your system. Because when I click on Carrie Ewell's here, maybe I get like 3 different names, and then it doesn't know which films to show me, and it doesn't know which movies to show me, or maybe it only shows me some films and not others, because all of a sudden it's not consistent in my database. So we kind of want to get around this problem, but we also don't want to add a whole bunch of columns. So adding columns, not great because it wastes space. Duplicating, not great because it can lead to data inconsistencies, which has its own set of problems. So what's the solution? And this sort of brings us to the topic of today, which is, how databases are actually set up. So the solution, it turns out, is that we can start dividing this information up into different lists. So instead of having one big spreadsheet, we can break it up into smaller pieces. I kind of said that this theme was going to happen over and over again in computer science, where we break things down into smaller pieces. So for example, we might have one piece of this spreadsheet just be people's names. All right, so what I'm going to do is I'm going to take these names and I'm going to copy and paste them over here. And what I'm going to do to them is I'm going to add an ID number. All right, so I'm going to say this is the user ID, because these are our users of our little spreadsheet address, whatever this is. All right, so I'm just going to give everybody a number, and I'll just start at 1 and go up. So everybody now has a number. And then the next part might just be addresses. So I might just say, all right, let me take addresses and break that up into a separate group. All right, so I'm going to copy these. I'm going to move them over here. Now, I'm just moving these in a spreadsheet, but in a database, we're going to see that these are going to be broken up into what are called tables. So this might be a separate table that just keeps track of names. And this might be a separate table that just keeps track of addresses. So I'm going to call this address ID. All right. And again, I'm just going to number these from 1 on down so that each one has a unique ID number. All right. And then I could do the same thing for phone numbers. Maybe I'll do phone numbers. I'm not going to bother with email because I think the point is going to be made at this point, but I'll add a separate table for phone numbers. All right. And let me put these over here. And then again, I'm going to have a phone ID. So phone ID. And I'm just going to make those from 1 to 2 to 3 and so on and so forth. All right, so now I've broken my information up into these separate lists, or again, in a database, these are going to be separate tables. Now the question is, how do I connect my information? All right, and this is what elevates the database over a spreadsheet, is that it makes it very easy to connect different tables and different lists. And we do these connections through these ID numbers, all right? In a database, these are actually called keys, all right? It's called a primary key. And we're going to use these keys to allow us to connect the lists and create those real world connections that we know exist between, people, addresses, and phone numbers. So we almost have to think about this in sort of like real world terms. Like people live at addresses, all right? And one person can have more than one address. And it's possible, depending on what your system is, that one address could have more than one person attached to it. So for example, Amy Amison lives at 12 Apple Street, but if Amy Amison ends up marrying Bob Bobson, they might live together and they might both live at 12 Apple Street. If we're thinking of these phone numbers as cell phone numbers, usually it's just, one person owns the cell phone number. You usually don't share a cell phone. So it could be like one person owns this number, one person owns this number, maybe one person owns these 3 numbers. But we use these keys to sort of make connections. And here's how it works. So let's say I want to do the phone numbers first. In this table over here where I'm keeping the phone numbers, I could add another column called user ID. And this column would tie back to this table right here. And I could be like, all right, this first number is owned by Amy. And maybe Amy owns this number as well, and Amy owns this number, but then this number is Bob's. And I could go and I could attach each of these numbers to someone from my user or first name, last name table. All right, maybe this one's 11, 12, 15, 20, 25, 23, 22, 18. All right, so all of these phone numbers, whoops, there is no 35, so that's not good, now have an ID number connected with them. And what the database can do is it can look at this and say, oh, this phone number has user ID 1, which is actually Amy Amison. This phone number also has user ID 1, which is actually Amy Amison. Like we can do this by hand as humans, just cross-referencing these numbers, but the database is going to be able to do it pretty much instantaneously. And the advantage of doing this is watch what happens if I need a new phone number. All right, if I need a new phone number, I no longer have to add a column, and I no longer have to duplicate anything. I just say, oh, okay, I need a new phone number. Let me go to my phone number table. Let me type in the number. Right? And then let me figure out who it's attached to. All right? And it does that instantly. It goes back and attaches that one to Quinn Quinson. I didn't have to add a column. I didn't have to duplicate Quinn Quinson's. Everybody's name is only listed once. Everybody's phone number is only listed once. I haven't duplicated anything. I haven't added any columns. I've just sort of broken it up into different groups, and then I'm connecting these groups via these ID numbers. All right, and that's sort of the big idea behind these databases that we're going to look at, is that we're going to break our information up into different tables, and then we're going to create these ID numbers to link and connect the tables in the most efficient way possible. All right, so let's do another one of these. Let's say I wanted to connect addresses and users. All right, so again, I said that more than one person might live at the same address, and each address might have more than one person. So we can't just put a user ID here because sometimes there's more than one number. So we can't just do like, oh, 1, 4 or 1, 3. We're going to see that that doesn't really work. So because we can have more than one user at the same address, we actually break it down further. And we make a new table that's just user ID and address ID. All right. And in this way, we don't have to duplicate anything. I can just say, oh, user 1 lives at address 1, and user 2 also lives at address 1, and user 1 sometimes lives at address 3, and user ID 4 lives at address 10, and user ID 5 lives at address 20, and user ID 5 also sometimes lives at address 10. And I can just keep creating these combinations, and at no point am I duplicating the names. At no point am I duplicating the addresses. I'm just creating this extra table that just shows me who matches up with who. And again, as humans, it can be kind of annoying to be like, all right, which user is 1, which address is 1. But a computer is going to be able to do this almost instantaneously. The other advantage here is if somebody updates something, it automatically triggers, cascades through. So if Bob changes his name to Bobby, I change it in this one place. Why do I keep using 3 B's? If Bob changes his name to Bob, it automatically connects to those other things because the ID number hasn't changed. So if I go over here and connect it to these phone numbers, it's already connected, and I only had to change it once because it's going back to that number 2, which has already been changed. Same thing with the addresses back here. If it looks for user ID 2, user ID was changed here. I don't have to change it anywhere else because everything ties back to this one piece. So there's going to be lots of advantages to sort of breaking things up into multiple groups and then using these ID numbers to tie those things together in the most efficient way possible. Okay, so now would be a good time for you to go to the other video that's posted in this assignment and watch that video. So it gives just a kind of another breakdown of the difference between spreadsheets and databases. And I'm going to warn you, it's very corny, but it does do a nice job of kind of talking about the differences. And then once you've done that, we'll pick back up over here. All right, so you can pause this and watch the other one. Welcome back. Did you actually pause, or are you going to keep watching this? Either way, hopefully you watched that video. Hopefully you enjoyed the amateur baker database. And in fact, I've got an exciting news for you. That amateur baker database is actually attached to your assignment. So databases are not a file you're going to be able to open from Google Chrome. You're going to have to download those to your actual laptop to be able to view them. So like, I'm going to just download mine from Google Drive here, but like I can't open this in Google Drive. If I try to open it, it's going to say no preview available, and I'm going to have to download it. So this is a file that you're going to have to download. Everything that we do on databases will be on your actual computer because we don't have a Google version of the database software. All right, we're going to be using something called Microsoft Access. So this is going to download. It does kind of give me a warning when I download that says this type of file can harm your computer. It's not going to harm your computer. You can keep this one. So you click keep there. It'll finish the download. It's going to end up in your downloads folder. And then we can double click on that and open it up. And it's going to open it up in what's called Microsoft Access. All right, this is the database software that we're going to be using in this class. When you open it and have downloaded it from the internet, you're usually going to see the security warning at the top that says some active content has been disabled. Click for more details. You can always just click enable content. All right. So again, I'm not sending you any sort of viruses, so it's safe to use. Now, on the left-hand side here, you're going to see all sorts of different things. All right. So we've got tables, queries, forms, and reports. All right. In this class, we're mostly going to be focusing on the tables and the queries. The forms and the reports are sort of specific to Microsoft Access, the software that we're using, whereas tables and queries are more or less the same in any database system that you use. So we're going to focus on this because this is more general to databases, whereas the forms and the reports are more specific to Microsoft Access. Out there, and let's just say, I don't want to say the real world because people use Access in the real world, but forms and reports are usually handled via web pages. All right. Forms are a way to input data, but if you're inputting data to a database, say like you're creating an account on Amazon or eBay or any other site, it's usually done through your phone or a web page. So we're not really going to focus on forms because this is specific to Access. Same thing, reports. You can kind of think of reports as almost like search results. Again, usually we're doing that via websites and web pages. So we're not going to really focus on these. We're going to spend most of our attention on the tables. So this opened up at the start. I'm just going to X this out. There's a little X in the top right corner there. And I'm going to double click on one of these tables. And what's going to pop up is something that looks a lot like Excel or Google Sheets. All right, we've got rows, we've got columns, and there's data inside of that. So up top, we have our column headings. This tells us what's being stored in the database. And then here's that ID number that I was talking about. And if I double click on customers, you'll see the same thing in just a much bigger setting. So again, we've got first name, last name, street address, city, state, zip code, email. Now, based on our example right there, in the sheet, I said break off address into a different table, break off phone numbers into a different table. In this database, it's all part of one table, which means they can actually support multiple addresses. And we're going to see that based on how you design your database is going to change what your system can support. And if you don't need your system to support multiple addresses, it's fine to put it all together. But if you want your system to be able to support multiple addresses, then you'd have to break it apart the way we kind of did in that spreadsheet example. And then we can go further and open some of these other ones. Menu items. Notice that these are mostly just ID numbers. All right, so these ID numbers tie back to other tables in our database. Same thing here with order items. We've got an order ID, a menu item ID. So this is saying that like order 5 includes product 179 and product 3. Order 7 includes product 19, 54, 34, 156. And if I were to open the products table, I would see all of those different ID numbers and what they actually correspond to. All right, so again, these ID numbers are sort of the magic that makes this database work and sort of connects everything that we've got going on here. All right, so the tables, again, they look a lot like Excel spreadsheets, but they are different and they have these ID numbers and they're going to be connected together. To see how they're actually connected, what I'm going to do is up here in this main tab, I'm going to go over to Database Tools. And there's something called the Relationship View. All right, and if I click on this, I'm going to see some of the tables, and there's going to be sort of lines connecting those tables. Now, right now, it's not actually showing all of the tables, but if I right-click and choose Show All, it'll show you all of the different connections that exist inside of this database. All right, so the products and the categories are connected so that we know that one category can have many products. Products can show up on menus. They can be part of sales. We've got orders that involve things. We've got customers making orders. So all of these connections that you would imagine in a real life business, we are going to represent in our database and have these connections so that the tables are can be combined and we can pull information together across multiple tables, because that's the advantage, or that's what we need to be able to do. Is great, we've got this customer table, but we have to be able to tie that over to this product table so that we know what they actually bought. And that's what these connections are going to facilitate, is allowing us to pull information from multiple tables. Now, how do we pull information from tables? That's where these queries come in. All right, so queries are basically another way of searching through the database. So if I click on this December orders, it looks like just another table, but this doesn't actually exist in the database. This isn't a table. This is a special search that we've done that's presented this information. And if I right-click on this tab up here, you're going to see an option that says SQL View. All right. In addition to right-clicking on this, I could also go to this View button and go to SQL View here, or I can also go down here to the bottom and go to SQL View. But whichever way you do it, this is SQL, which is structured query language. And this is the language that we're going to be learning how to write and to use. All right. This is the language that gets used to pull information out of a database. All right, so it specifies what you need to pull out. It specifies where you're pulling it out from. It specifies any conditions that you want to place on that. And it specifies the order that you want it in. So this is sort of the language that programmers use to interact and retrieve information. And what we're going to see is it's far more robust than your VLOOKUP and your HLOOKUP. All right, we're going to be able to do a lot of things with this that we wouldn't be able to do in Google Sheets. But as we learn this, you're going to start to see this in the sites you interact with. All right, if you do a search on a site, you can start thinking of that as like, okay, what would the SQL be that would generate that search or give me back these results? Let's just go back really quick here to, we'll go to Amazon for a second. All right, so I'm going to go back and search for forks. Right? Most websites, when you search for things, have this little option that says sort by, and it gives you different options to sort by. That's something that you can specify in your SQL query. So when I say, oh, I want to sort this by average customer review, that changes the SQL query and gives me back my results in a different order. If I change price high to low, that changes the SQL query and gives me back my results in a different order. So there's all sorts of ways that we're going to be able to change our queries. Over here, we have like different checkbox, like, oh, I only want products that are Amazon Prime eligible. So if I click that box, it changes my query and gives back specific results. All right, that's what we're going to learn how to do over, the next, 4 or 5 classes. We're going to learn how to write this language, which is the driving force behind a lot of the sites and systems that you interact with on a daily basis. And you can open up a few more of these if you want and look at the SQL. Some of these are going to look a little more complicated than what we're going to be doing, but they give you sort of a feel for what the language looks like. All right, there's certain keywords that we're going to learn: select, from, group by. Those are all words that we'll be dealing with and kind of learning what they mean and how they work. Now, down below here, I'm just going to show you some of this other stuff. Customers, all right, this would be the forms that I were talking about. We're not actually going to make these, but you can see how they kind of look like a web page. All right, you could think of this as like a web page you would visit and type in your information and then submit it. That's what the forms are. They're sort of Access's version of a website. And then the reports are basically just a fancy way to display your information. So instead of just displaying it in a table, it displays it in sort of a formatted report that you can look at and make look pretty. But it's basically just information from the database that's being presented in some sort of formatted manner, as opposed to just being in a straight table where it looks more like Google Sheets or Excel, right? So that's kind of like just a little walkthrough of the database, all right? We're going to spend a lot of time with this over the next few weeks. You're going to get very sort of familiar with it as we work through different activities and assignments. And eventually, this is what your project is going to be for the end of first quarter. All right, you're going to build one of these databases from the ground up. And don't worry, we'll go over how to do it. We'll take it slow. But you're going to build one from the ground up. And then you're going to be required to write a certain number of queries that actually pull information out of the database. All right, so that just gives you kind of a feel for where you're headed and how this all is going to play out. All right, so next class we'll actually learn, or not learn, but we'll start the process of learning how to design a database and see how that all works and comes together. All right, so I hope this was helpful. Have a nice afternoon, and I will see you when I see you. Bye.